Here we have a picture of a point x naught y naught at the center of a circle of radius r. We ask the question, what's the condition for which, or the condition that has to be satisfied if the point xy is to lie on this circle. In other words, we're going to find what's the equation of the circle, the equation being the algebraic expression of the condition that xy lies on the circle. So let's think about it. What does it mean for point xy to lie in a circle of radius r? It means that xy lies at distance r from the center of the circle. What's the center of the circle? X naught, y naught. So xy lies at distance r from x naught, y naught. There's the condition. Okay, so we say that xy lies on the circle. IFF stands for if and only if the distance from x naught, y naught to xy is r. We translate that very easily into algebraic form. The distance from x naught, y naught to xy is this square root here. We set that equal to r and square both sides, and we have x minus x naught squared plus y minus y naught squared equals r squared. This is the equation of the circle through x naught, y naught of radius r. It's the equation of the circle in the sense that if x and y satisfy this equation, then the point xy is on the circle. And if the point xy is on the circle, it better satisfy this equation. It has to satisfy this equation. Okay, this figure is in response to a question that was posed. If a circle has diameter with endpoints at 2, 4, and 10, 4, okay, then what's the equation of the circle? Now, none of this stuff that you see here was given. The only thing that was given is that the circle lies, that a diameter of the circle goes from the point 2, 4 to the point 10, 4. Well, if we have the endpoints of a diameter, we can find the equation of the circle. In the first place, the center of the circle is halfway across the diagonal, so it's going to be at the midpoint between these 2 points. The midpoint between these 2 points is the point 6, 4. If we just average 2 and 10 and average 4 and 4, we get 6 and we get 4. Then the question is, what's the radius of the circle? Once we have the center, you see, if we know the radius, we can write the equation of the circle. Well, from the center of the circle out to either end of the diameter is the radius. So from the point 6, 4 to the point 2, 4, we can find the distance. It's rather easy to find since the y-coordinates are both 4. 6 minus 2 is 4, and that's going to be the distance from here to here, which means that the radius of the circle is 4. Now I'll note a couple of things. These points both have the same y-coordinate. It's not necessary that they do have the same y-coordinate. Any 2 points, any 2 endpoints of a diameter, the midpoint of that segment is going to be the center of the circle, and then using the fundamental triangles, the distance formula, and so forth, we can easily find the distance from the center to either of the endpoints of the diagonal. In this case, it was easy. We got 4. So, this tells us the center of the circle is at 6, 4, the radius is 4. It follows that the equation of the circle is x minus x naught squared plus y minus y naught squared equals r squared. X naught is 6, y naught is 4, and here's our equation. And we can square the 4 and write that as 16, and this be the most standard way of representing the form of that equation.